just let's go to the first question on analytical geometry. M34 is the center of the large circle. So I'm going to stop reading. This here is the center of the largest circle. And it's also a point on the small circle that has a center at 0. So that's interesting. 0 is the center of the smallest circle. M is a point on that circle, which means the line MN could possibly be a tangent. Okay, so let's wait. Let's not get too excited. Let's wait until we read that that is a tangent. Only then can you start filling in those relationships. Please, folks, when you do any type of geometry, if it's analytical or normal geometry, Euclidean geometry, you have to read that things are the way they are. You can't go by what your eyes tell you. Okay, so we've heard that this is the center, so we can say those two are equal. They are indeed radii of the smallest circle. Okay, now from N, the point 11, negative, and P, so from this point, there we go, a tangent is drawn to touch the circle, the largest circle at T. So at T there's a tangent, and what do we know? That if that is a tangent and it touches at T, I'm going to put this in as a dotted line, that this tangent will definitely be perpendicular to the circle at the point T. But it's not just perpendicular to the circle. They say to us, it is also parallel to the y-axis. So we've got that indicated quite nicely. I don't know how that is going to help us, but I'm sure there's a reason for them telling us that those two lines are parallel. My eyes looking down at it, and I'm thinking, now where's the transversal here? But maybe we'll see just now. Maybe we do need that. Okay, then they say NM. Now remember, we haven't read this yet. Here they say it for the first time. NM is a tangent to the smallest circle at M with MOS the diameter. So MOS is the diameter of the smallest circle. MN is a tangent, so again, we have a right angle there. There's a tangent perpendicular to a diameter, and there's a tangent perpendicular to the radius of the big circle. Okay, and I think that is just about as much information that we can draw on. Yeah, I don't think there's much more for us to say here. Okay, so let us go and let's see what is the first question that they ask. They ask us to determine the equation of the small circle. Now, folks, if you can remember, the small circle was centered at the origin at 0, 0, and it had a point that passed through it. Have a look. Just remind yourself, it's centered at 0, 0, and it passes through M. So if a circle is centered at 0, 0, then we can say x squared plus y squared is equal to. There's no other point that we subtract here because the center is at the origin 0, 0. Then the other point that we had is the point -3 and 4. So we can say, okay, that would mean that this here is the same as -3 squared plus the 4 squared. That gives us 9 plus 16, which leaves us with 25. So the equation of that smaller circle, x squared plus y squared, is indeed equal to 25. Now remember, the radius is always the square root of that 25. Okay? Center is at 0, 0. The radius is 5. Let's see what they want now. The second question. They're asking us, determine the equation of the circle. This time the circle is centered at M, which is up here. in the form, and you can see the form that they want us to leave that circle in. So they don't want you to multiply things out and distribute brackets and do all types of funny things. Okay, let's have a look at the information we've got. We've got the center of the circle, which lies over here at M. We now want to have the radius of the circle. And we don't have the radius yet, folks. They did not give us information there. So let's see if there's something here that we can use. Have a look at this. If we look at this tangent that I drew in, the x value at this point is -3. Now remember, this point is the center. The x value at this point here, because it's parallel, now we see why they had to tell us that these two are parallel, because that means they share x values. It's perpendicular to a line that's parallel, so this will be the point -11 and 4. How sneaky was that? That was quite clever. They gave us the point t without giving it to us. Okay, we had to go and look for it. So it is -11 and 4. So I've got 2 points. I've got t, which is -11 and 4. And I have the center of the circle, which lies still at -3 and 4. And if I look at the difference there, that is where my radius is. My radius will be 8 units. The difference between those two horizontal points gave me the radius. Okay, so now it's just a matter of writing down the equation. Remember, that's the center. So I get x minus -3 is x plus 3 all squared. Remember, they said leave it in that form. Plus y, and y is a positive 4, so it's y minus 4 all squared is equal to this 8 squared, which we calculated with the symmetry in those points. So this gives us a value of 64. So r is 8, r squared, however, is 64. Now notice that that was, what, for a good 3 marks. Okay, so far nothing challenging. We've got 5 marks in our pocket for this question. Let's read and see what the next section asks us. Determine the equation of NM. Now I've got to go back. NM is this line over there. We want its equation. Now that's quite interesting. I'm going to put these up here. X minus, what was it? X plus 3 squared plus y minus 4 squared is 64. And then we know that this equation is x squared plus y squared. And that was equal to, what? Let me just check again. That was equal to 25. There we go. So if we need it, we've got it. Okay, now if we want the equation of Mn, we've got the point M, we've got the x value of n. We absolutely do not have P, which is the y value of that point. And yeah, I don't think we can, I suppose, try and get to it, because there's a radius of 8 here, and there's a vertical distance here. Okay, it's not. The vertical distance is 4 minus p, so sorry. There's no ways for us to find p. We need to find another way to find that equation. And that comes in here where they told us that this is a tangent. Okay, it's a tangent to this diameter at the point M. So we can find the gradient. The gradient is just 4 over -3, because it's the gradient from a point to the origin. Okay, so the gradient of this point, let me go back to our page. The gradient of our point here is going to be -4 over 3, because it runs from the center of the big circle to the origin. That's where that little diameter runs. Then we have the point M, and that point M was the point that they gave us right at the beginning, -3 and 4. So, yes, what do I have? I have the gradient of the radius. Let's make that r for radius. So the gradient for the tangent, notice it's for 4 marks, will be 3/4. It will be the negative reciprocal of the gradient of the radius. Why? Because they're perpendicular at the point M. Okay, so quite something to remember. You don't want to stumble over this simple little negative here. Okay, and then we can go. We've got the gradient, we've got the point. So y minus 4 over x plus 3 is equal to 3/4. We cross multiply. 4y minus 16 is 3x plus 9. And then our final result, let's keep the 4y for now, is equal to 3x plus 25. And then what did they tell us? They wanted it in mx plus c. So y is equal to 3/4x plus 25/4 as a y-intercept. And there's the equation of my tangent. Okay, now we're definitely going to need that because we need to find the value of p sometime in our problem. So let's go back and let's put it on the equation on the graph. The equation of that tangent was y is equal to 3/4 x plus 25/4 is the equation of my tangent mn. Okay, so let's see what they want us to find next. They say we need to find, let's see, find the length of Sn. Now we've got to go back and we've got to go and check where's Sn. S is down here and N is way up here. So we want the length of that line over there that I'm now highlighting. Now folks, if you have a circle is symmetric in its origin. So if you have the point AB on a circle, BA lies on the circle, minus A minus B, minus B minus A minus B, B minus A. 1 point on a circle, you've got 8 points in total. So let's have a look. If I want to write down the coordinates for point S, I've got to see it is 3 units to this side. I'm reflecting it in the origin over here, and it will then be -4 in the y direction. So S is the point 3 and -4, and they want us to find the length of NS. Okay, so we have to now go and possibly find the length of P. Can I find it? Of course I can. All I need to do is take this y, which is 11, and put it into the x, and then I have my value for P. So the x value that's -11 goes into the x. Whatever comes out is the y value. Okay, so let's go and answer that question. It's quite a, I think it must be it's 5 marks, so it should be a few more, because there's a lot of work for us to do over here. Okay, so what do we have for point S? For point S first, we said it's the point 3 and -4 is point S. And then we also had the point N, which was -11 and P. Now that we're going to use in the equation y is equal to 3/4 of x plus 25/4. Remember, that was our tangent, and the point N lies on the tangent. I just need to put the -11 in there. Okay, and then what happens to the y? The y becomes the P value. So here we go. P is -33 plus 25, all of that is divided by 4. Okay, so this gives me, I hate fractions, so 4p is equal to, at the top, if I take that away, I get minus 8, so p is negative 2. Now, I don't know, I think I've earned 2 or 3 marks possibly from the 5 that's on offer for this question. I'm not finished yet. Remember, the question said find the length of Sn. So whenever I want to find a length, I need the distance formula. So in I go. The length of Ns or Sn, whichever way you want to write it, is 3 minus, let's start with the 3, the x value here, minus 11 becomes plus 11. That is all squared, plus the negative 4 here, minus 2 becomes plus 2. Folks, don't stumble over those negatives. We saw that p is negative 2. And a double negative immediately turns into a positive. Okay, so let's quickly fix this one. It's 100, or it's 14 squared plus, what is this? This is just normal 4. So 14 squared is 196 plus 4. In the root is the root of 200, and that is simply just 10 root 2. 10 root 2 is the length of our line Sn. Okay, we can put it on our diagram in case we need it. So let's go to the diagram. P was minus 2, and Sn, which is here, was the length 10 root 2. So this is the point minus 11 minus 2. Okay, so now for the final question. They say to us in this particular one that, let me just make space for us here, a little bit of space, yes. If another circle with a center B minus 2 and 5 is drawn with a radius k, it's drawn in such a way that it will touch the circle that is centered at M. Okay, so let's do a diagram. There's the circle that is centered at M. That M lies over here. I'm just going to put M, and the coordinates for M in this case is still minus 3 and 4. Now they say there's one that lies 1 unit to the right and 1 unit up. So that is now a circle with a center of B. And B has the center minus 2 and 5. And now they're asking us, they're saying to us that determine the values of k if the radius of this circle is indeed k. Now, folks, there's two things here. For this circle to touch the blue circle that we've got, I'm just going to sort of draw the diameter in there. The one circle will be centered there and will sort of come in and touch and go, yeah, something to that effect. Then there's a second circle with a bigger radius. So this yellow circle touches the given circle internally. Then there's one that touches it externally. I'm trying to draw my circle. Oopsie, look at that. Oh my word, that is a little bit shocking. I was just about to say that the word is out there that if you can draw a perfect circle, you are close to genius. So clearly that shows I'm not. It's still showing I'm not. But folks, you get the idea. So I need to find out what is this short distance between the two, because I know that from here to here we have 8. So let me do that in another color. From the center there to the circle, and from the center there to the circle, the blue circle, there's a radius of 8. The new circle has a radius of k. Okay, so that k plus this little bit in the middle here. I hope the green shows. Yes. So let's go and try and find that distance. Now, folks, you'll see the distance lies over there. MB is the square root of minus 3. Be careful of your negatives. Minus 3 minus minus 2 becomes plus 2, all squared, plus 4 minus 5, all squared. Now, that doesn't take a genius to see that this is 1 plus 1, so this is simply just the root of 2. Okay, so now I can write down these radii for 5 marks. I thought it was going to be far more difficult than that. Okay, so let's go for the smaller circle first. Okay, the smaller circle lies from here to there. It comes with the 8 that we had. So for, let's just say that's K1, or that, how can we say, for the smaller circle. For the small, let's just write it out. For the smaller circle, we had the radius K, 8 for the big circle, minus this root of 2 that was taken away here, formed the value of K for the smaller circle. For the bigger circle, the value of K will be the 8 that we had over here. Remember, there's the center. There's the initial 8. So that will be 8 plus the root of 2, which gives you the value of that K. Yeah, and that was the first 19 marks. Question 4. Quite a nice, interesting question, folks, but you had to absolutely know what to watch out for in that diagram.